Okay, hi, my students. Okay, watch this. Today in the classroom, we did two examples of trigonometric identities 7.1. So let's see, I took one problem. This is problem number 3. We need to verify whether this expression is the same as the expression. What I did is I took once the left hand side. In this case, I took the right side, and in this example I took both left and right. So one of the strategies that we can use is you can do both left and right together and see whether at the end we get the same thing. So the first step is let's replace tan. Tan is sine over cosine. So let's apply the property that tangent is, this is equal. So I'm going to replace this tangent as the orange color as sine y divided by cosine y. And then I'm going to replace this cosecant is by reciprocal identities, which is 1 over sine y. On the right side, this secant can replace by this 1 over cosine y stays the same, and replace this secant as 1 over cosine y. That's the reciprocal identity, where secant is same as 1 over cosine. Now we can use keep, change, flip. So what this means is, if I have A divided by B, C divided by D, this is, you keep the numerator, so this is the numerator, this is the denominator, so it is the numerator times reciprocal of denominator. That means it is the numerator is A over B times the reciprocal of C over D, C, D over C. So it's keep, change, flip. So you keep the numerator, change the division to multiplication, and flip the denominator. So I'm going to use the same thing here. So this sine, cosine y stays the same. Then this is the numerator, this is the denominator, and you flip this sine y divided by 1 equals, same thing, this is the numerator, that's the numerator, and this is the denominator. So keep, so the minus, keep, and flip this, which will be cosine y divided by 1. Okay, so so that you see sine times sine, 2 sine will give you sine square, and we can use Pythagorean identity where sine square, applying the Pythagorean identity, sine square is 1 minus cosine square. We can replace that because sine and sine will give you, okay, let's try this step, sine square y divided by cosine y. So this equals, I think I missed one step there. So this is, I'm sorry, this one I missed equal, this one cosine stays the same, and this is minus 1 times flip of this cosine y divided by 1. So this equals, and now you see there's a denominator is cosine, and here there is a 1, so we need to have the same common denominator. So I'm multiplying numerator by cosine and divide by cosine here. So this will be cosine, and cosine is 1 minus, so this one stays the same. Cosine and cosine will be cosine square of y, and this will be cosine y. Okay. And then we get at the end I'm gonna keep this as it is, so this will be sine square y divided by cosine y equals 1 minus cosine square, right here by Pythagorean identity is sine square. So this will be the top part is sine square y divided by cosine, and they are the same, so verify. So the question was, is this identity true? So we get both same answer. Okay. Now the question is, next is another strategy we could use is, can we begin with the left side and get the right side? So let's set that up. So this one is, I begin with the left side, tan y. The first term is everything stays there here until here. So I'm going to write this. This was the left, right? So because this is the left. So whatever this you started, you ended up with the left here. So I'm going to begin with this part. So tan y cosecant square, we ended up getting sine square. So we did get sine square y. So this is what we got, right? So I'm beginning with this step here. Everything stays the same. You do this step, and you do this step, you do this step. Okay, it's the same thing, right? This and this is the same thing. So I begin with sine square y, and our goal is to get this 1 over cos, 2 parts. So the only way to get these 2 parts is, it's like going backwards. So the step 1 is sine square y, you will change it by 1 minus cosine square y. Okay, so I'm using the sine square y, replacing it by 1 minus cosine square. And then we apply, suppose you have a minus b over c is a over c, b over c. So you can separate the denominator. So this cosine y divides 1 and both. So this will be 1 cosine y. This will be cosine square y and cosine y. So I like, sometimes I forget. Then there are two cosine here. There's 1 cosine here. So one of the cosine, this cosine will cross out with this. So what is left is 1 over cosine y minus cosine y. And then this cosine y, because you want to get, your answer has to be secant y, right? This can be rearranged, and I'll keep this as cosecant, cosine y, and this we can write as, it is this way, right? So we can always write this as 1 divided by 1 over cosine y. Or directly also, so this is cosine y, which is same as 1 over secant y. That's because secant y is 1 over cosine. So the definition of secant is same as 1 over cosine. So cosine is same as 1 over secant. So they are one and the same. So we can write cosine y equals. This is the second strategy. Let's start with the right side. Suppose we begin with the right side, 1 over cosine. The first thing is you do the same step. You change secant to 1 over cos, and keep change flip, and you end up getting this one. So I'm gonna start with sine square cosine. So this is what we got. Let's say you start with this. This is what we get. Sine square y divided by cosine y. Okay. So you begin with the right side. Okay, do the secant y is 1 over cosine, keep change flip, get the same denominator, and 1 minus cosine square. That's what you got. So you start with the right side, and you end up getting this. Now the question is how to get tan y, kind of a little trickier, because you need to get 10, right? So at the back of your mind should think the only way to get 10 is I need to have, there is already sign here, so you need to have a cos in the denominator, but there is a square there, so I have to have one sine divided by, and then at the same time, there's a cos y here. You don't want to have a, you want to have a cosecant here. So a little tricky, then watch what I mean. So keep sine square y and cosine y as it is. And both the numerator and the denominator, let's divide by sine y, cosine y, sine y, cosine y. And then you can see this sine, one of the sine y will cross out, and this cosine crosses out, and this, the numerator there will be sine. So what I left with is sine y, cosine y, and here it is 1 over sine y, which is sine over cosine is tangent y, and the denominator 1 over sine using the reciprocal identities is cosecant y. Anyway, so 3 different ways to do the same problem. Seems to be this one is a little hard to get. I'm gonna say, hey, that's this little hard to do. So to get right side to left is a little hard, but left to right was kind of easy because you have to change sine square to 1 minus cos square, and then you get the answer. But I think this was the easiest, right? So sometimes as you practice, you know which one to take. So hope that helps. So this is one of the problem I thought of showing all the strategies that could be used to arrive at why is this correct. So that was problem number 3, and I will follow up with the next video showing maybe 4, 5, and then I'm going to build up a lot of proving trigonometric ideas. Thank you for watching. Hope this helps. Yeah, practice is the best teacher. See you. Wait for the another. I'll make a few more problems I will solve. I have 4, 5, 6. The next video I'm gonna show 4, 5, 6. Thank you.